Hello dear students, I am Professor Mandar Dikshit from Electrical Engineering Department. Today we will study about node voltage method, or it is also called as node analysis. In this method, we are considering node voltages in the given circuit. This method is based on Kirchhoff's current law, that is KCL, and the method is useful for calculating voltages or potentials at different nodes in the circuit. The analysis is carried out by considering one node as a reference node. Usually the common node is considered as a reference node. After determining the node voltages, all branch currents can be determined in the given circuit. To understand this method, we will solve a simple example. The statement of the example is, by node voltage method, find the current through 15 ohm resistor in the following circuit. The circuit is given. This is my 15 ohm resistor and I have to calculate current through that resistor using node voltage method. The first step to solve this example is that we have to mark nodes in the given circuit. From the definition, we know that every junction of network where 3 or more branches are connected together is considered as a node. In the given circuit, there are 4 nodes, 1, 2, 3 and 4, where 2 or more branches are connected together. The lower nodes are same, hence they can be connected or joined together and considered as a reference node. Generally, reference node is selected as a node where maximum elements of the circuit are connected together. To these nodes, maximum elements of the circuit are connected, hence it can be considered as reference node. Hence, our lower node in the network is considered as reference node. The circuit will be simplified by denoting nodes and reference node such as Now let us mark the node number 1. Node number 3 is considered as reference node. Generally, reference node is connected to ground to indicate as common node. Let us denote let V1 be the unknown potential or voltage at node 1 and V2 will be unknown potential or voltage at node 2. Also, we will define unknown currents in the circuit. So this is my I1 current, I2, I3, I4 and I5. According to Kirchhoff's current law, sum of incoming currents is equal to sum of outgoing currents at any junction or node. If we apply KCL to node 1, the incoming currents are I1 and outgoing currents are I2 and I4. Hence, at node 1, by applying KCL, we will get equation as I1 equal to I2 plus I4, where I1 is incoming current towards node 1 and I2 and I4 are outgoing currents from node. By Ohm's law, we can write down the currents in terms of voltages and resistances as I1 will be written as, if you observe the circuit, I1 is flowing from 100 volt battery to node 1. Hence, I1 can be written as 100 minus V1 divided by 10. Similarly, I2 can be written as I2 is flowing from node 1 to node 2. Hence, potential difference between node 1 and node 2 is V1 minus V2 divided by its resistance 15 ohm. I4 is current flowing from node 1 to reference node. Generally, reference node potential is considered to be 0 as it is connected to ground. Hence, potential difference between node 1 and node 3 is V1 minus 0 divided by resistance 20. Substituting these in above equation, we get 100 minus V1 divided by 10, which is written for I1, V1 minus V2 by 15 written for I2, and V1 minus 0 by 20 written for I4. After solving this, we get final equation as or more simplified so 4V1 minus 2V2 is equal to 300, equation number 1. Similarly, we will apply KCL to node 2. At node 2, incoming current is I2 and outgoing currents are I3 and I5. Hence, addition of incoming currents is equal to addition of outgoing currents, which will give equation at node 2 I2 is equal to I3 plus I5, where I2 is incoming current and I3 and I5 are outgoing currents from node 2. Again, by Ohm's law, I2 can be written as I2 is again flowing between 1 and 2, so the potential difference is V1 minus V2 divided by resistance 15. I3 is the current flowing from node 2 to 80 volt battery, so potential difference will be V2 minus 80 divided by resistance 10. I5 is the current flowing from node 2 to reference node, so potential difference between these two nodes is V2 minus 0 divided by 20, where 0 is the potential of a reference node connected to ground. Substituting these values in the node equation, we get V1 minus V2 by 15, which is I2, V2 minus 80 divided by 10, which is I3, and V2 minus 0 by 20, which is I5. After solving this equation, we will get simplified equation as minus 4V1 plus 13V2 is equal to 480, that is equation number 2. By solving equation number 1 and 2, we will get values of V1 and V2 as V1 as 110.45 volt and V2 as 70.90 volt. Hence, the current through 15 ohm resistance will be I2, which is given by I 15 ohm is equal to I2, which is given by V1 minus V2 by 15. If you substitute the values of V1 and V2, we will get answer as 2.63 ampere, and the direction is from node 1 to node 2. Hence, the current through 15 ohm resistance using node analysis technique is 2.63 ampere. Thank you for watching this video.